Hello guys, I welcome you to BMS Projects Limited, where we design and build classic homes. I welcome you back to site. This is episode 6, the making of Project Demian. We want to push this sand towards that end. And we can push it towards that end so that we can have the whole of this space to ourselves. First floor slab, everything that has to do with the first floor slab, the beams, reinforcements, the carpentry work, the M&P jobs, and everything that has to do with the first floor slab. That's what we'll be leading you across. So I welcome you back to site. So today we have an interesting thing that we have to talk about. On this living room, this is the living room, the dining, and the helical staircase is on this. So when we came on board, the structural engineer actually did reinforcements on this span. We have about 6.2 meters on this span here. So he actually did have over 3 of this span, across at 600 mm depth for the beams. So when we came in and we saw that the beam made us have our headroom reduced. Our headroom was almost getting to 3 meters. So when we saw our headroom at 3 meters 2.9, we didn't like what we saw, so we had to go back to the drawing table. So the structural engineer will have to task him to find a way, to give us a new design of the beams that can make us, have a considerable headroom on this span, despite the span that we'll have, So that is why I also want to encourage you guys about, having a synergy between the architects, the structural engineers, mechanicals, and electrical. Everybody must be on the drawing table to make the project a success. So because of that, the structural engineer had to go to the drawing table and he started, and he came up with a wonderful design that can make us have our depth of the beam reduced from 600 to 450, so that we can at least have our headroom to be a bit considerable. So with that 450 beam, the implication is that we're going to have more reinforcements on those 3 beams. So when we have more reinforcement on those 3 beams, that will give us the opportunity to do what? To still have our headroom. So the aesthetics, when we are looking at the POP design, the ceiling and everything, it will come out the way it should be. So the beams can still be very, very functional without it affecting the beam. So that was a very wonderful thing that we did. And we thank God we've been able to resolve that. So if you look up here, you can see the new beams, which is 450 beams. But inside the beam, the reinforcements have changed.
Initially on the design, we have a 6.2 meter span.
Yes.
And an effective depth of 450 mm.
Yes.
But the architect came and complained because of the headroom we have. So we had to reduce the 450 mm effective depth of the beam to 300 mm. Now, when you're making such reductions, you have to compensate for the loss of strength that is coming on the beam. So if you can see, we have a spine or a mid-span beam running in the middle of the 6.2 meters beams to support this curve we have on the staircase. So now, dropping or reducing the depth of the beam, we also need to compensate for the strength by adding extra reinforcements. So in the original design, we have 3 wide 20 mm and 3 wide 16 mm on the top zone of the beam, 3 wide 20 mm on the bottom zone of the beam, then 4 wide 12 side bars on the sides of the beam. But due to this modification and the complaint made by the architect, we have to modify our design to having 3 20 mm at the top zone, 4 20 mm at the bottom zone, then 2 side bars, 2 16 mm at the side bars. The reason for the side bars is because we have a beam running at the mid span of all the 6.2 meters beams here. Now, running the beam through the mid span will cause a flexural stress, like the beam will try to twist because we have a cantilever at the tip. So the cantilever, the point load and the cantilever load on the tip will make the beam to twist because of the load. So we put side bands to counter any flexural stress we're having on the sides of the beam. So what we have currently on ground can still also serve the purpose of the architect for the head width and also compensate for the strength of the beam.
By so doing, both the structural part of it, the architectural part of it is a balance. So that is why it is good to, involve your professionals. Don't let them go. Don't feel that one other person can. Everybody must be on the round table to make it a success. So by doing that, we're able to achieve a functional space. Structural engineer actually did justice to the beam arrangement. The structural calculations for this project is massive. It's so great. He was able to balance the building. The way the building is, you can imagine the spans that we have here, how he was able to balance them. Look at how our vertical staircase is. We have a very generous 2 big windows there on this part and on this part to throw in light into this living space. And just on this same helical space here, we have a dining space here. Dining will be received by a generous chandelier that will just drop down there with 2 amazing windows of ventilation. So this will actually bring in light into the space. So we are still on with the helical staircase. For now, the carpentry work is almost done. They will be covering it up and we'll start off with the reinforcement details. Okay, so on this helical staircase, we have about 6 meter length, total length of 6 meters, and the width is about 1.5 meters. And on this 1.5 meters, you can see how generous the width is. About 4 persons can move comfortably on this without no fear of fall or without any hindrance. So now, another interesting thing we did on the thread is our thread point A is about 150 mm, while the thread point B is about 225 mm. So with that too, you can actually move and step comfortably without any fear of fall to actually achieve this.
They hear me? The bottom iron now, where come from this decking now, when they go down, go like this, link with this one where they see now. Then the top one, when they come now, go like this, go like this.
Now our electrical and mechanical service engineers were not left out. We reviewed all the drawings, made sure all the lighting points, CCTVs, air conditioning, piping, and all services were factored in. It's always satisfying to get in everyone's input as it helps to produce a great project. Now we have satisfied every curiosity, crossed our T's, and dot the I's. We are ready to receive the concrete. Just take a good look at our staircase reinforcements. Are they not amazing? Are they not wonderful? Think quality construction, think vehemence, think amazing architecture, think vehemence, think interior, wonderful finishing, think vehemence. Our next job will always remain our best job.
Staircase is looking more like it right now. You see how our risers are. So sweet. So thank God for the success of this particular phase and this thing.
Project limited, building right all day long.